Hi, welcome everybody. My name is Xavier, also known as Javier. I'm going to explain you how diesel engines works, also known as pressure combustion engines. We are going to start here with this cylinder block. The cylinder block is the main structural body of the engine that houses all the cylinders where combustion occurs and support essential components like the crankshaft and the camshaft. Without the block, no internal combustion process could take place. Now, the second most important part is the pistons. There are the pistons. The pistons convert the energy from the combustion into a linear motion. As the air and fuel mixture ignitions, the expanding gases force the piston to downward, generating the mechanical power that drives the crankshaft. The connecting rods link to the pistons to the crankshaft. They transfer the piston linear motion into a rotational motion needed to produce usable mechanical work. Now we have the crankshaft, as that one was mentioned before. The crankshaft transfers the up and down movement from the piston into a rotational energy. The rotation is what ultimately powers the vehicle. Basically, to a diesel engine, we can attach almost everything that has like a rotational input to it. So they are the ones who transfer their movement to the thing that we have attached. We have also the cylinder heads. The cylinder heads close the top of the cylinders and contains these critical components like intake, exhaust, valves, and sometimes injectors. That is our case because as we are working with our pressure combustion engines, we need to create pressure and heat. That heat is created by air that once it gets compressed, it gets hotter. And when we add fuel, as we were looking to our practice before, the combustion just happens. It's like spontaneous. And that's why the cylinder heads are too important, because they manage the airflow also in and out of the combustion bay. We also have the fuel injectors and valves. We have one for intake and one for the exhaust gases. The valves control the entry of the air through the intake valve and the exit of the combustion gases through the exhaust valve. Their price times ensures proper combustion and the engine breathing. That's the most important part, because without the engine breathing, we cannot start or move anything. The fuel injectors deliver the diesel fuel into the combustion chamber at extremely high pressure, and in a diesel engine, fuel automatization and injection timing are crucial for power efficiency and emissions. Because I don't know if you were looking on the streets, like some of the trucks, some of the special gear that we use powered by diesel engines, also you see like a huge smoke cloud, black and dirty. That's handled by the injectors and all those post processes of those gases. So basically, with a good set of injectors that manage the right pressure and the exact timing, we're going to avoid those gases to go to the atmosphere and create nasty processes over it. We also have the camshaft. The camshaft opens and the valve and closes the valves at exactly the right moment in the cycle. It is synchronized with the crankshaft through a timing belt, chain, or gears. It depends on the use, but most likely every single time that we see a diesel engine, they use chains. Why they use chains? Because they are so durable, and as diesel engines has a lot of torque, we cannot attach a belt into it because we're going to break it. So basically, the chain is the most important part that drives the energy from the drive shaft to the camshaft, so we can have everything working at its exact timing. And the turbocharger, they increase the airflow by pushing more air into the intakes, and we create extra pressure input into the engine, so we have a better combustion. The intake manifold is in charge to distribute the fresh air to each cylinder evenly, properly airflow ensures better combustion and smoother operation. Basically, with a good intake manifold, we're going to redirect the airflow to each specific cylinder at each specific time. We also have the excess manifold that as the intake manifold, they just manage the excess gases, and that allows the engine to work properly. That reach the injectors with fuel. That's also important because the injectors they just splash the gas into the chamber, but the fuel pump, it allows the pressure on the system and the diesel, and they move the diesel from the tank to the injectors at a high pressure. Without the proper pressure or the proper pump, the injectors cannot function correctly, and that's why we also see a lot of cars throwing black smoke on the streets. We have also the cooling components like the radiator, the water pump, and the thermostat. Those allows the right parameters to run the engine. We have the cooling system that is mainly for the cooling that we see, like sometimes it's green, sometimes it's red, and also allows the engine to work perfectly. And we have the lubrication system that we also see here. So every single engine needs to have a lubrication system. They need an oil pump and an oil filter. The lubrication reduces the friction between moving parts. Again, the engine might run rarely without lubrication, but catastrophic damage will occur. So basically, if we have two metals together, they are just going, without lubrication, they are just going to end up together, and that's going to break the engine.
From a very young age, Ron experienced I was able to understand the advantage of the diesel engine, and a good part of the explication in this video will justify the reliability the provided in heavy-duty machines. According to the first law of the thermodynamics, when a gas is compressed, increase in temperature takes a strict rate to the internal energy. This occurs rapid is possible approximates an isentropic and atmospheric adiabatic process main in is absolute way that in the high transfer out of the system or losses are minimal. The pressures 1 and pressures 2 in known since the rate and real the pressure in the combustion chamber. For the fuel to enter in must the injection a heater pressure 2. And other lies the importance of the correct functioning of the injectors in diesel engines. This diesel engine can achieve a compression ratio between 34:1 and 25:1 results in lower operation RPMs and therefore less fuel consumption, which in the great advantage. This process takes place through a compressor diverted on exhaust turbine or blades. Very good, gracias.
Hi, good morning, good afternoon, and good night for everyone. I'm Juan Camilo Arias, and this is a presentation and overview of the types of compression ignition engine. Like the other slides before, in the fundamental sense, an internal combustion engines convert the chemical energy available in the fuel, conventional petroleum based, through combustion to thermal energy, and through expansions of the working fluid converts the thermal energy to mechanical work. This process occurs with the working fluids, like, for example, air from on and fuel to combustion products. Exchanges on a repetitive cycle with combustion occurring in a closed chamber. So, uh, these topics, principal topics, two-stroke cycles, four-stroke cycle, another expense, and split cycle engines. The first of all, the two strokes. These two strokes, the conventional internal combustion uses crank slider mechanisms to convert the linear work imposed on the piston by the gases in the combustion chamber, like I told you so before in the start of this presentation. The cylinder volume of the crank slider mechanism is maximum, like the Vmax and the BDC, the bottom dead center, and 180 degrees before the TDC, the top dead center, like this figure, like you see in the left of this presentation. The internal combustion engines operate in the two conventional cycles. The two-stroke operational cycles include the two strokes over one crankshaft revolution, the compression, and the power or expansion stroke. Eh, as the piston moves, it exposes ports to control exhaust and the inlet flows, and opposed to using separate intakes in the exhaust strokes, as they will be discussed in the four-stroke. That will be the next one, these slides. The limitations of these two-stroke engines are mixing of the incoming fresh charge, which or with the exhaust residuals and the passage of the fresh intake charge directly into the exhaust system due. Well, this is because the scavenging process resulting in the high emissions. For the four-stroke cycles, the four-stroke operational cycle, as the ICE includes intake, compression, expansion power, and exhaust. There are two crankshaft revolutions for the one power stroke. The intake stroke involves the movement of the piston from the TDC just for clearance of the minimum cylinder volume to the BDC, to the bottom dead center. For an intake port fueling in the CI engine, the fuel air mixture is inducted into the cylinder. The next stroke is compression stroke with the piston, like a BDC to the TDC. That's important in this situation. We have an alternative engine operating cycles, like a overexpanse cycle. The overexpanse engine cycle is variant of the standard four strokes engine. This engine cycle. In the standard cycle, for example, the Atkinson cycle, in the practice, the Atkinson cycle can be achieved by changing exhaust valve opening, opening and the intake valve closing timings relative to the BDC for the bottom dead center. Cycle we provides the improvement in efficiency since there is additional work output, increasing the area under pressure on the building curve. The Miller cycle, the second one, is the modification and overexpand cycle, the left one, which provides a higher expansion ratio than compression ratio. In practice, this difference in expansion ratio can be achieved through a compression stroke, which includes a late or early closing of the intake valve. This split cycle is the last but not least one of the most important of this presentation, because engines really of multiple cylinders to provide the operating cycle for the engine. A typical of these configurations is two pair cylinders, one for intake and compression, and the second one for the power and exhaust. And this is the last what I'm going to say to you. I hope you understand of this overview of the type of the compression engines. Just let me know if you have any question. Thank you very much.
Okay guys, to continue, my topic for me is about the application of compression ignition engines. I'm gonna show you a little bit of this video. What is the operation, okay? Okay, now I'm gonna show you a little bit of evolution of compression ignition about diesel engine in timeline. Yeah, you can see in this video between 18 and 92 until present. Yes, present is 20 and 10. Yeah, I'm gonna show you a little bit of what is the process in this evolution. In this evolution, it is about how fuel diesel patent the first compression ignition engines. Then the first fully operation diesel engine. After that, we can find the first fully operation diesel engines. Then the miniaturization begins early diesel engines for small machinery and trucks. After that, we can find the Bosch develops mechanical fuel injection system, increasing precision and power. It's too important to know that. Now the diesel becomes essential for submarine ships, tanks, and heavy-duty equipment. Yeah. In the middle, we can find the diesel becomes essential for marine ships, tanks, yeah, and heavy-duty equipment. Yeah. After, we can find the first modern turbo diesel car. Yeah, car appears like a Mercedes, Peugeot, Volkswagen, etc. After that, we can find a modern car like turbo diesel cars appears like most cotidian in cars, Mercedes, BMW, Peugeot, etc. In this year, we can find a high-pressure electronic improved injection system significantly increase the power and the efficiency. And the present, we can find the ecological transition begins hybrid diesel, system advanced biofuel diesel. Yeah, and then we can show you some application in the industry. Yeah. Okay, I'm gonna show you the first. First, with the image, we can find the road transportation, trucks and buses. The application is heavy trucks and buses, rally and CL engines because of their high torque and dress for long haul and urban heavy duty uses. With the second, we can find the marine industry application. The application is about diesel, CL engines, power chips, offshore rigs, line industry generation, etc. With the third, we can find the agriculture and construction. We can see in the image. We can find tractor, excavator, machinery commonly using CL engines for their durability and low speed torque, like tractor, yeah, and low RPM, pulling heavy equipment. With the four, we can find the rail and heavy marine transport, large scale transport, This electronic locomotive or massive marine engineer rely on all long life and high power. For example, we can find freight train locomotive powered by alarm diesel engines. Yeah, for example, chief, main propulsion engine, backup generator, and industrial plants. With the file, we can find the passenger cars, diesel variants. This application is many passenger vehicles adopt diesel CNG for economic and torque allow speeds. For example, we can find in the image like a diesel sedan or hatchback with a sub turbo diesel engine. Okay, thank you very much for the video.